All right. What so one of the things I thought about doing was um kind of explaining uh oops, hold on. Are you on the live stream or are you on the well, okay. Do you have a YouTube account that you can like post comments in the chat while I talk? It's delayed. Okay. All right. End the phone call. If you have an account, you can put in chat so I can know what you're talking about. But yeah, I think it's gonna be weird if you try to listen to me. All right. So, uh, hey Dad, how's it going? This is an idea that I had because we're um, I g- I was thinking about if you don't if you do have an account, feel free to enter it into the chat now that we've got the phone confusion out of the way. But anyways, so let me kind of give you some context of why I want to do this. Is one of the things that I learned, or like I work in data science, and I know how these tech companies are working. I understand the algorithms behind it and the data. And what I'm afraid of happening is that as the increase in content that's available to us, our um, just every generation of you know people that use the internet, it's going to be harder and harder to capture the attention of other people. And there's this really important like data science article that came out in like 2018, I think it's called "Attention is All You Need," and basically it's I don't want to get like way into the math, but uh, essentially it like um, the algorithm takes all the data, kind of breaks it up, decodes it, and then like brings it back, and then um, it calls these things like attention layers that like fight it out, and then you predict your output. And the paper itself is more talking about what is being used for um, like ChatGPT, those large language models. One of the key things that uh, does these um, like manages the attention layers they're called transformers, which are they're transforming the decoded and encoded data, and then like uh, uh, I mean, at the end of the day, it's just trying to predict. Man, I had I had made slides like this week so that I could like talk about it more coherently, but I'm sorry I'm botching it. But the point is like uh, I'm afraid that we're heading into a future where the family bonds, the real world connections that we have, are going to be increasingly um, uh, worn out and like pulled apart because of how these tech companies and data science platforms are exploiting our attention um, for just for clicks and views and advertisement. And so in I had thought about creating a video for you that would explain some of this. I think that's why it would have been better to have some slides to show. But I thought, you know what, what's better than making sure that I have your attention than like actually creating a live stream where I can kind of talk about these things. And that's not all I want to talk about. There's a couple things I'm part of it is I just want to like do some free um, uh, kind of improvisational work. If you figure out how to create an account and put in some chat, I will uh, respond to that. Or if as we're trying to get it set up on the phone call, you tell me a topic that you want me to talk about, then we can go into that. But the I think the intent is to see if you like this. I mean, like, this is literally content that I'm making for you. You are my only audience member here, and I want to know if you like this. If it may not make sense at first, but and if you don't um, uh, I would try it again for sure, because I think what I'm I think that what I need to do, like there's probably like some therapy thing that I'm trying to do for myself here, where I need to just reestablish a better relationship with my father. And because I have this type of brain that I think came from just how you raised me, is like I'm always trying to think at this like universal scale of the eternities and things like that. And so in order for me to do something like this, where I reach out and reconnect with my dad, I have to pretend like it's a big thing and like an art performance. But I think at the end of the day, I'm just trying to have a conversation with you. So um, yeah, there's a lot of different kind of subtopics that I've thought about going into, but one of the ones I wanted to really start with was I actually finally read your the science papers that you want to publish about ethoxylation and um, haze, and I wanted to give you my feedback. And wanted to share with you like uh, some thoughts I had about it. I pulled um, in this Chat GPT um, to help me create this. Um, like just some ideas about it, and honestly, it's what helped summarize it for me, because it was very dense. Your writing style is, you know, exactly what I'd expect from a scientist. Like, it's not beyond what I can comprehend, but there's a lot of jargon and like language terms, and just like chemical. Um, if I were a chemist, they would be like, "Oh yeah, like obviously, the ethoxylation process. That's obvious to everybody how to do it." And but for me, like I had to like ask ChatGPT, like, "Can you explain to me what's like actually happening here?" So what's cool is like I understand it better now, and I can actually I made some notes on it. So the first paper I want to review is um, let's see, the very first one. Let me developments in alcohol ethoxylation catalyst technology, right? Um, so I learned a lot. Like it took me a while to like, because every kind of step of it, I had to go out and like find out what the process was and what these things were, and is really interesting. So if I get any of this wrong, y- uh, I'm sorry. Like either you're gonna have to like correct me in the chat or send me an email, or just I don't know, let me get it wrong. But as I understand it, these alcohol ethoxylates are it's the how you make the surfactants that go into the consumer products, right? And the one that's kind of mostly out there that gets used, or at least what you were using when you were in the biz in the business, was uh, sodium hydroxide. And what your paper showed is that uh, potassium hydroxide is um, uh, a, of the caustic catalysts, potassium hydroxide is more, I don't know, it just has less like byproduct. And then you compared the NRE, narrow range ethoxylation, um, process with calcium. I don't really know how that one like um, stacked up. Like I honestly, oh, he's calling me. Hold on. What's up, Dan?
Can you hear me?
I can hear you now.
Okay. Well, I'm glad you read them. If you read those and can understand them, you know more than most chemists and engineers in the business, because that explains pretty much everything. But these alcohol ethoxylates, if it's just a couple of moles, it's not water soluble. And so you don't use those like that. You sulfate them. You add H2SO4 on there and then neutralize it. And then that is ether sulfates. It's used in shampoos, it's used in laundry soaps, it's used in dishwashing soaps and all that stuff. If you have about 6 or 7 or 8 moles on there, then it is water soluble. And then those are used as is in laundry detergent liquids.
Okay. So, um, well, so you don't have a YouTube account?
No, I don't think
Ah,
so.
man, you got okay. Well, one of these times we got to get you set up.
You don't need to worry about AI and all of this technology getting in the way with me, because I just don't mess with it. I watch the videos of YouTube just for the news, but that's it.
Yeah. Okay. Well, I can circle back to that because there's two things I'm doing. Um, and I'll sum it up. But let me get through. I want to like I'll go through I'll show you the notes that I had ChatGPT make for me, which will be interesting, and then talk through those, and then I'll uh, tell you the last thing.
Okay.
You can see the cat. Just this is May. I don't know if you see her
Yeah, I
in the
see
corner
her.
her here, but she's one of Jess had a cat that had babies, and I'm taking one of them. This is the other two. I'm cat sitting the other two. They're outside, but anyway. So let me share my screen so you can see the um, you just tell me if you can see this screen.
Not yet. Okay, now
All
I
right.
can see.
All right. I'm gonna end the call, and I'll kind of just monologue through this,
Sure.
and then we'll end it on kind of a philosophical note that I had ChatGPT write up for me. All right. I'm gonna end it now. Go back to the stream. All right, Dad. So, um, and again, I know I'm gonna get this wrong, but it's really not that important that whether or not I get it right or wrong. Well, no, I guess it is. I mean, I want to like make sure I understand it, but I want to tell you. I'm more interested in telling you like the ideas that generated out of me reading it. Like that's what I wanted to, So, uh, the um, I guess I should go to the paper, but each of these are alternatives that are better than the status quo. This one's I don't know who's going to be like uh the that this double metal cyanide. This was really interesting because I kept asking like what a normal consumer would basically want to ask about this paper. Like, okay, well, if sodium hydroxide is more um, has more byproduct and is like potentially worse in the manufacturing process than potassium hydroxide. That's, what do I care? I just care about if it's like worse for my skin and stuff like that. And so I asked ChatGPT to kind of like give, uh, pros and cons and like understanding uh which of these catalysts were like the safest, and like what it doesn't understand, Dad, is because all the data gets thrown together and like mushed together, all they have, all of um uh the data only has like extremist, like environmentalists, or consumer, like basically people who say any chemical in my consumer products is bad, versus the scientists who have said, this is fine. Like there's just not really a lot of like people that are talking in this narrow realm of language. And so the large language model comes in and is trying to like be balanced and arbitrate between it. And what it did is that it saw the word cyanide and just thought, oh, well, cyanide's toxic and bad, therefore it shouldn't be used for consumer products. But like what I wanted to ask you and to correct or whatever, or maybe this is like pe- peer review for the paper, is like just kind of helping people understand that like whether or not a metal cyanide um, catalyst that has the um, uh, benefits of higher quality ethoxylates and fewer byproducts or impurities or whatever. Like to me, it was kind of like, is this a situation where it's like sodium chloride, where like the chloride in salt is bad, but like, or the chlorine is bad, but not the NaCl, So anyway, let's see. I kept yeah, so like here it's going through uh I mean, it like when I'm asking it questions about whether it uh like, which one has a better health and environmentalist impacts, it's kind of just like giving, it's too evenly balanced, thinking like, well, it's caustic, corrosive, it's gonna hurt. Oh, he's calling in. Hold on. This is- we need we need to think of something where we
I can't tell if you can hear me or not,
I
but
I
I can
can't
hear.
I can't hear you. I'm just like monologuing outward towards you.
Okay, well, let me address your concerns.
Okay. They're not my
Okay,
concerns. They're just my question. Like they're just
all right.
information is being generated in my brain as I'm
Sodium
reading it.
hydroxide is a catalyst that we at Conoco Vista Condea US was using, but nobody else was using. Everybody else was using potassium hydroxide.
Mm-hmm.
When I was in Italy, they showed me how much better it was. And so when I came back from Italy, I finally had to convince all of our people that we got to get with the program because everybody else is smarter than we are. And we were just going along fat, dumb, and happy doing with sodium hydroxide when it had all these problems. So they made the switch finally. I convinced them to make the switch. So we switched to potassium hydroxide. Okay. Well, then there was the calcium catalyst, which is the narrow range. And I don't know if you saw the picture that had those curved distributions with all the points on them. The calcium hydroxide gave the narrowest range, and that was the NRE, the narrow range ethoxylate, that Sasol does and not too many other people do. And we got up to about 100 million pounds a year of that stuff, of that products made with that.
Which picture are you talking about? Oh, the NRE. Yeah, yeah. The e
And you see three curves.
yeah. The
The
green
sodium
curve is like
hydroxide,
a
the potassium is a little bit more peaked, and the calcium hydroxide,
Here,
NRE,
let me share
is
it
the most peaked.
for the streamers.
We're now on the 4th generation NRE because I invented number 3 and number 2. And it has several advantages because it runs faster, it makes a narrower distribution, it has less free alcohol, it has less PEG, which is a byproduct. The only thing that it has is this haze. Now, in my last 2 years before I retired, I did a lot of work with the DMC. The DMC catalyst is very expensive, but it also works at a very low concentration. When you use potassium hydroxide, you use 600 ppm of potassium. When you use the narrow range, you use 35 ppm of calcium. When you use the DMC, you only need to use 5 ppm, 5 to 10 ppm of the DMC. And of that, the cyanide portion is only about 1 ppm. So the concentration is so low, it wouldn't have any toxicity for it. But the problem is the catalyst costs like $4,000 a kilo just for the catalyst.
Jeez.
And so Bayer makes it, but also there's some Chinese companies that make it. And it works pretty good too. I tested some of the Chinese stuff. And so I started the company, both the Germans and the Italians, using the stuff. The Italians got some of the Chinese stuff and used it. And one of the Italian guys told me, he says, this stuff is amazing. It's like you take a little tiny teaspoonful of this white powder and put it into the reactor, and it goes. And it makes water white, water clear product with very few byproducts. The only problem is it adds about a couple of cents on a per kilo basis, a couple of euro cents per kilo, because it's so expensive.
Mm-hmm.
But for ethoxylation, it doesn't speed up anything over just the NRE. And it's a whole lot more expensive than the NRE. And so for productivity concerns, where you're running your reactor and you want to make so many kilos in a 24-hour period, and you can run it and get 3 times as much with the NRE than you can, say, with sodium, or twice as much with the NRE than you can with potassium, it doesn't give you any extra fast running for ethoxylation with the DMC, so it isn't worth the cost. However, there is another reaction called propoxylation, where you use propylene oxide instead of ethylene oxide. And you make these special kind of surfactants that are used in oil field recovery stuff. These are surfactants that might cost $5 a pound, whereas your typical household thing costs $1 a pound. And so for propoxylation, you can run 5 ppm of this DMC catalyst, and it'll do the reaction in a half an hour that it would take a full day to do with KOH or with NRE. And so you can justify paying the $3,000 to $4,000 per kilo for the white powder that's DMC as to paying the much cheaper price for potassium hydroxide or narrow range ethoxylate, because you can make so much more in your reactor on an hourly basis, on a 24-hour basis.
And the output is the same.
The output is no, because with potassium hydroxide, it comes out brown, it's cloudy, it has this sediment in it, and it has about 4 to 5% byproduct in it. Whereas with the DMC, it doesn't have any of that. This is for the propoxylation, for making these specialty oil field stuff. And that's not discussed in the paper, really. That's why it says this actually merits its own separate paper.
Yeah.
I did all of this in my last 2 years. Like I said, I did my best stuff in the last 2 years before I retired. And so we started, and the Italians were starting to make some of these specialty surfactants that we could sell for $5 a pound into the oil field market. But we were using, the problem is they're white powder, and you can't really stop and open up a reactor and take a teaspoon and add your white powder into the reactor when you've heated it up to 150 degrees Fahrenheit, no, 150 degrees centigrade, and you've tried to keep the air out of it. So what we do is we found that we could slurry the white powder at 1% in 99% of the NRE slurry, and then you can add it as a liquid. And so the NRE third and fourth generation were used just as an additive package to carry the DMC white powder. But again, this wasn't for the whole household surfactant because it added too much cost for no extra time in running.
Yeah.
It was for just the propoxylation for this oil field application. And it was incredible how you could do KOH, and it would take all day to add 10 moles of PO onto the alcohol, where you could do it with DMC, and it would, in a half an hour, it would do those 10 moles.
But
In
like,
fact, you had to slow the reaction down to try to keep from temperature from getting too high on you.
but so like in the ethoxylation process, when it binds the the chains to make the surfactant,
Yeah,
if
the ring opens up and adds on the EO unit.
Yeah, if
or a PO unit.
when you do that, if it's DMC, is it? I mean, like the AI didn't know. It saw the word cyanide and just thought poison.
Yeah.
It didn't see DM like it's.
No,
Is it any less safe than the other ones molecularly?
not
Like the
really,
output
because
that'll end up in your
you're
soap?
using so little of it.
Yeah. Okay.
The DMC is zinc, cobalt, with some cyanide ligands on it. So if the zinc and the cobalt make up about 60%, and it's only 5 ppm, then that means there's only 2 ppm of the cyanide ligands. And you use it at such a small amount, it doesn't really, but you see, you wouldn't really use it for household and personal care applications because you don't gain anything in terms of increased productivity for reaction with EO. But for the oil field, where you're not worried about whether
Yeah.
it's got cyanide in it or not,
Yep.
in the oil field, it runs so much faster. It makes the product so much
Oh.
purer and clearer. And
So for
without,
oil spills, I think there was. I saw an oil rig getting blown up in one of these like Russian Ukraine war videos, and I was like, so like that type of cleanup, like, or the BP oil spill, is that where?
it's an additive to the drilling fluid that they send down into the hole.
Oh.
They perforate the formation, and they pressure force this stuff out into the formation, and it increases the flow of oil and gas back to the wellhead, that they can pump more oil out of the ground.
Could you also use it for fracking?
Well, yeah, that's exactly
Okay.
what fracking
But I
is.
mean, but not in the ocean. You could use it in land fracking too.
Yeah, and so the idea is that you improve the productivity of the oil well 3 or 4 times over what it would be without it, and so you can justify paying $5 a pound for this stuff.
Yeah, but you wouldn't want to do it on land fracking because it all that fracking stuff gets seeps into the water. Like they don't really. Um,
Again, it is so low in concentration
there's probably
that it
like more
really doesn't
cyanide
matter.
and
Yeah.
pharmaceuticals or something like that. Yeah.
Yeah, it's just that AI thing sees cyanide go
Well,
berserk.
that's what I'm saying. Like this is kind of one of the things I want to try to show is that like because there's been a lot of discourse that's highly polarized, you know,
Yeah.
about this issue, the
I mean,
LLM does not understand how to like it doesn't know the nuance, and the experts who do understand the nuance are um uh aging like you, and
yeah.
the most of us who are younger, and I'm not saying like I'm
Well,
the type of intelligent
you get problems like
person.
environmentalists. In that first big paper, in the first 4 or 5 pages, it
Yeah, you
has a
talked about it.
discussion about dioxane, 1,4-dioxane.
Yeah, actually, I
And
asked
there's a thing
questions about
about
that.
some environmentalists says ethoxylation is a cheap method that dirty chemical companies use to make their products milder, which is all a bunch of horseshit. You know, you do the ethoxylations, and using all of these catalysts that we talk about, you really don't form any 1,4-dioxanes. At most, a couple of ppm. The dioxane is formed in the sulfation reaction. And again, these environmentalists are too stupid really to know the difference. They just see one thing and want to,
But
like environmentalists, they want to draw too much attention
I
to
understand, but like you gotta, from their point of view, or from the algorithm's point of view, the it its opinion carries equal weight
yeah,
because of it. It just doesn't know. It doesn't have real world experience. It only has the words that we put in paper and
yeah.
submitted. And so, if you have a bunch of activists who have over the years generated just lots and
Well,
lots of
that's why in
literature.
my paper I listed a couple of references to HERA, HERA. It's the Governmental Environmental Research Association or something. And basically, it's the results of that says that 1,4-dioxane isn't really a problem.
Yeah.
Now, what can be a problem is if you have any free ethylene oxide left over. If you're doing the reaction and you end up with extra EO left over that hasn't reacted,
Yeah.
what happens at the end of the reaction, you add acetic acid to stop the reaction. And once you add the acetic acid, any free EO in there, it can't react anymore. So it's just stuck in there. And so the specification that Sasol had on all their products was no more than, or less than 1 ppm of free EO.
Oh wow.
You couldn't have anymore.
Is that
Because,
was that a European standard that
no,
came,
that was
or
a Sasol one.
but like did they steal it from Europe, like the
No,
ISO? Okay.
no. See, Shell actually, in their case, said they allowed up to 6 ppm. But Sasol was no more than 1 ppm. And the reason is, here's an example of what happened in Europe. Okay. There was this one plant that was making ethoxylates, and they had a big tank, and they kept routinely finishing their products and pumping it out before the EO was completely consumed. And so they'd end up with 10, 20 ppm of free EO left over in the liquid after it had been quenched with acetic acid and it had cooled down. And so it sits in the liquid. Well, what happens? EO is very volatile. And so in the storage tank, it comes out of the liquid and ends up in the vapor space of the gas above the liquid, in the vapor space there. Now, normally that's nitrogen and not any oxygen.
Not flammable.
But the idea is you have nitrogen on because you don't want the ethoxylate to ever get heated and to oxidize, because it gets dark, ruins the color. Well, there was a case of a guy who was inspecting the headspace vapors above each of these tanks. And so he'd open up a hatch and look down in, and the stupid guy had a lit cigarette in his mouth.
Yep.
So he opens up the hatch, he sticks it down in. The explosion from the EO, because it is very combustible, very explosive, kills him.
Yeah.
Blows him off the tank. Next thing, he's shaking hands with St. Peter at the pearly gates. And so you don't want to have any free EO in the liquid. You want to get it all reacted down to less than 1 ppm before you pump it into the storage tank. So EO is very dangerous. 1,4-dioxane is not so dangerous. Yes, it is toxic, and yes, it does have a problem, but 1 ppm isn't going to kill you.
Yeah.
But unfortunately, the state of New York has made a ruling to say that all of these personal care products have got to get to be less than 1 ppm of 1,4-dioxane in these personal care products.
Yeah.
Shampoos.
Meanwhile, the Chinese market is flooding with makeups and soaps and stuff that are like full of lead and crap like that, because it's cheaper, and Americans are just buying it off of Temu or whatever.
From India. Or from
yeah,
China,
because and so we're literally killing our own industry to promote the worst health outcomes from countries that don't. Yeah, anyways, that's
a case of where a little bit of knowledge is dangerous because they just don't really understand.
Yeah. So, well, that's interesting, and
So I convinced Sasol and Conde at the time to switch away from sodium hydroxide to potassium hydroxide. I convinced them to try to use narrow range ethoxylation catalyst as much as possible because it was so much faster. And I made I got a patent application for number 3, and then I turned in the stuff for number 4 just before I retired, but they didn't prosecute it for a patent, because to get a patent on something costs them, say, $200,000 or $300,000, and they don't want to spend the money, But I think they're using the NRE 4th generation catalyst that I developed, and that's the stuff that's kind of the subject of the Hayes paper. And basically, one of the things it says is that, like most dumb engineers, they don't want to care about when you switch from one catalyst to another. They want to make this product, and if it's potassium hydroxide, fine. Then they want to make this other product with narrow range catalyst, and that's fine. And they want to switch back and forth willy-nilly without paying any attention. Well, the problem is the potassium hydroxide used a 600 ppm of K+. The narrow range catalyst is used at 35 ppm of calcium plus 2. And so if you get any left over, and see in a reactor you have a recirculation loop that has a cooling coil, you have about 200 gallons of hang-up. And, that's 4 50-gallon drums.
Yeah.
You have about a reactor between one batch and the next. And so if you've gone from doing a KOH batch, then you decide now you're going to run an NRE third generation or fourth generation following it. The problem is you'll get a carryover of about 10, 15 ppm of potassium into the narrow range ethoxylation catalyst batch. And that ruins it. That's the subject of the Hayes paper.
Yeah, that one I do have here. Dad, one of the things it's very, the environmentalists made a lot of content, okay? Because everything I kept asking, it kind of just like, it just has this general bias of trying to like push like BS green products. Like it would be like, oh, these are more sustainable, like, and I'm like, it's the same palm trees. Like they're the same palm, like you're not getting
coconut or
coconut palm oil, that's what I meant to say.
Or Ziegler is ethylene based.
Is that the method that Sasol? Well, I guess I don't put any like proprietary stuff on here, but
no, it does. It's not proprietary. It's all been published.
I saw it. I read the Wikipedia article on the Ziegler method. So, anyways, one of the,
how you can tell the difference if you look at the gas chromatograph for a 1214 cocoa or a 1214 palm kernel or a 1214 Ziegler. You really can't tell the difference because they're all, linear, primary, even carbon chain alcohols, 2 peaks, a 12 and a 14.
Mm-hmm.
You know how you can tell the difference?
No.
In the radioactive background, the carbon-13 content of the coconut and palm kernel oil, because they're grown in the South Pacific, which up until the early 60s or the mid 60s, the French were doing nuclear weapons tests in the South Pacific that would put a higher level of carbon-13 radioactive isotope in the ecosphere. Those natural alcohols have higher radioactive content than the Ziegler, which comes from ethylene, which is in the ground for.
So the irony is, like, the green soaps are actually nuclear compared to that's hilarious. Anyway, that's funny. Well, I want to keep these like short. If like I'm having fun though, but I don't know what. There's a couple interesting things I wanted to hit, but we can save it for another night.
Well, I can tell you, if you can understand those 2 articles, you'll know more than probably 90% of the chemists and engineers out there who are actually involved in this business.
Well, I mean, I guess I'm streaming it live, so do you want me to take it, make it private?
No.
The articles, though.
Go ahead.
All right.
Go ahead and put it out there. I want to see it get published, especially the one about the Hayes, because all these many years we fought this problem of the customers. See, what it is, the customers didn't want to pay any extra money. All of our management thought, well, it's narrow range, so it's got to cost more. Yeah, we'll make more money out of it. And we said, no, they're not going to pay anything more. If you offer it to them at the same price, they'll say, okay, yeah, that's fine. But they'll complain about the haze.
Yeah.
And the thing is, we make more money making the narrow range stuff because it runs faster. We can get more productivity out of our equipment. We can make more pounds, on a 24-hour basis. We don't have to tell the customers that and charge it the same price for the other stuff. But anyway.
Well, but Dad, the MBA in me says they're right to charge more for it if it's perceived to be higher quality or higher value or whatever.
Yeah, but the customers aren't going to buy it then.
Just because they just want the cheapest. It's okay. Actually, you know what? That makes sense too, because
it's a practical experience.
the
You can
procurement.
argue all you want to try to sell more, but if nobody buys it, what the hell good does it do you?
Yeah, I guess what you got to do then is like lobby the market to like require people to buy your version.
If you can make the same product and sell it at the same price, but instead you make more money, an extra couple of cents a pound difference in margin because you're running it so much faster and putting it through your equipment, you don't have to tell your customers that you're making more money off of it.
Yeah. Okay. So this was interesting. I was asking it like, are there any other catalysts worth exploring? You mentioned that the DMC one might be like a whole other paper, but this was completely. It came up with it on its own, as like basically you. The intent of me asking the question was, let's say, Dad, if you were like 30 years old and you still had 20 years at Sasol, what would you be researching and whatever? What other catalysts out there would you explore? And I put she because I had it.
Well, the fourth generation catalyst is made with 4 ingredients.
Well, are you watching the stream? It came up with these ones. I just want to know if they're even in the realm of what you're talking about, or like if I want to see if these ones were interesting in any way, or if they're way off the mark. Like I'm trying to test if. So, you can keep me on mute on the stream, but or just like don't put your headphones on.
No, I'll just listen to it.
But like if you watch the stream, I've got it up here. So, when considering the scalability and investment potential, a few factors should be taken into account. Cost of technology, cost of raw materials, blah blah blah. But like they said, heterogeneous catalysts with novel supports, metal organic frameworks, and graphene supported catalysts. Are these even in the realm of?
Well, anytime you get to something like graphene or crown ethers or any of these other kind of things, it's more expensive.
Yeah. Okay.
The fourth generation catalyst is made with lime. It has to be a special grade of lime from Mississippi Lime called MicroCal HFT20. It has to be anhydrous sulfuric acid, 98% pure sulfuric acid. It has to be 2-ethyl hexanoic acid, which is a chemical reagent. And it has to be the 3-mole ethoxylate of 2-ethyl hexanol. Now, you can't get any more than about 8% of the lime slurried up with all of these ingredients. And you can't neutralize any more than about 70-80% of the lime with the sulfuric acid. See, the sulfuric acid reacts with the lime, which is calcium dihydroxide, and it forms gypsum, the crystal structure of gypsum.
Mm-hmm.
And it's got waters of hydration, 2 waters of hydration that are locked into this crystal structure. And so what I would do, if I were back, I've been waiting for somebody, like I used to consult with Dow or with Oxiteno. And if they ever came to me and said, what would you do to make it better? I would say, well, let's take a look at 2-ethylhexanoic acid and 3-molethoxyl of 2-ethylhexanol. And let's try some different branched alcohols and different carboxylic acids. I wouldn't change the ratios that much. I would just change those 2 ingredients to see if there was any in that space that had a lower potential energy or something.
Yeah.
And so if any of those did, I'd say, okay, yeah, you could do that. And that'll give you a next generation. Maybe it'll give you some patent coverage. But the thing is, Sasol didn't want to spend the money to prosecute for a patent. So if somebody else were to come and ask me how to do it, I'd have to say,
I need to end this
they
stream.
never patented this stuff. And so what I'd tell them is, you go back to the 1997 patent by John Lynn and Upali Weerasuriya, which is already expired. It's from 97 to now is what, 27 years? And patents were only in force for 17, 18 years. And so that patent is completely open for anybody to do whatever they want with.
All right.
And that talks about those 4 kind of ingredients, but it doesn't talk about specifically that 3-molethoxylate and the others.
Would you do like just a normal design of experiment for that? Like, did you follow that methodology, DOE?
Yeah, I mean, I would do maybe 3 different chain lengths of the branched alcohol and 3 different chain lengths around the 2-ethylhexanol. See, that's a C8 with a branch at the second carbon. So I'd do 2-propylheptanol. That'd be a C10. And then I'd try to do a 1-methylpentanol. It'd be like a C6.
Okay.
But
it came up.
I'm not in a lab anymore. I really can't do that kind of
It's
stuff.
not good. You could simulate it and build some.
Well, the only way to simulate it is actually prepare the catalyst.
Yeah.
And then you have to test the catalyst to see how fast it runs. Yeah. And there's another paper which I don't reference in there specifically, but in this other paper I do give the recipe for the 4th generation, this other report. It's a confidential report, but
so
this is how you'd make it. And the thing was, fast as a 3rd generation. And so what that meant was I could run the reactors at twice the productivity rate because the catalyst ran twice as fast.
Yeah. All right. I gotta let these other cats in, but these other ones, it came up with zeolite based catalyst, solid acid. I think that's one that companies already use.
Well, the thing is, zeolites are rocks.
Yeah.
And so you have to filter them.
Crush them
to
up.
get the stuff out. You can't leave it in the finished product.
Oh, okay. And then
so there's extra pennies per pound.
or nano catalysts.
What catalyst?
They call it. So again, this is. Have you heard of hallucinations in the AI?
Mm-mm.
It'll make up things that don't exist, and it will be wrong. But sometimes the
Mm.
hallucinations might actually be interesting to think about.
Mm.
It says nanocatalysts, nanotechnology is rapidly advancing. The production of nanoparticles is becoming more scalable. The challenge lies in maintaining the stability and preventing aggregation of nanoparticles at larger scales. Magnetic
Well,
nanocatalysts offer the added advantage of easy separation and recycling.
the Germans had a program that they wanted to get started, and they wanted to use it was kind of a nano reactor, just a flow through reactor where you didn't actually have a batch, but you just flowed the stuff
Oh, cool.
through to get the thing to react. And I says, "You're wasting your time." I said, "What do you know?" I said, "Look, we have over 200 recipes for
Mhm.
making products. The Italians have over 500 recipes for making products. None of these are big enough that you can just continuously make one thing. If you could only make one product, a continuous reactor makes sense. But if you've got to make all these different things, and a batch here and a batch here and a few drums and a truckload here and a rail car here or whatever."
Is that the kind of business that y'all did? Like everyone would come and say, "I need this specific
Well,
recipe."
most of the engineers like continuous reactors. They like continuous
Oh
processes.
yeah, but
They like to have everything running, and once it's in line and is producing, they just want to make and go and go and go and make
well,
lots of
like
pounds of that one thing. Well, the problem is there are some businesses that lend themselves to that, and there's some businesses that don't.
yeah.
And
Well,
ethoxylation don't.
isn't that kind of like how yeah, I mean like I, operations supply chain style like totally makes sense why they'd want to be continuous, but I agree with you like I mean there's a reason why companies like um they call them
Well,
like boutique um
if you make specialty products,
yeah.
or if you make products that have to be neutralized at the end, at some point you have to stop. You have to put it all and mix it up in a reactor, in a big batch reactor. You have to add the acid or base or whatever it takes to neutralize it, to bring it to pH and call it good, and then you can package that.
Yep.
But when you're just continually running one thing after another, um, there's only a few products that are like that. And there definitely are. For example, the sulfonate LAB to make linear alkyl benzene sulfonate. The acid is stable. You make it, you put it in a big tank, you put it in a rail car, you can ship it. That lends itself well to continuous process. And the plant that runs that, for example, you run your plant making linear alkylbenzene sulfonic acid on the weekend when you have a skeleton crew,
Mhm.
because it just runs continuously. And once it's lined out, it's just going to go and just keep making stuff. And you can keep putting it in a tank. And there's another thing you have to worry about. If your feedstock occupies one full tank and your product occupies 1.2 full tanks, that's okay. You have a place to put it and you don't run out of space. But let's say your feedstock occupies one full tank and your product occupies 4 full tanks. Then you've got a problem. because you can't run forever because you can't move the finished product fast enough.
Yeah.
Now in the lab where you're just making stuff on a beaker size scale and a couple of liters here, whatever, you don't have to worry about that. But if you got rail cars, if you got storage tanks or whatever, you got to worry about that.
Yeah.
That's one of the things that where my experience in Italy really helped out compared to a lot of the other guys.
Because you had like on the
They
ground.
say, hey, we can't just run forever on this because we got to have a place to put it.
Yeah. In theory, though. Anyway, hey, it's late. I gotta get to work tomorrow, but
Okay.
let's do this again. Well, you tell me. Do you want to do it again? Because
Sure,
I.
that's
All
fine.
right, and I'll up the technology because there's yeah parts that like um I want to figure out how to get you to just because I don't know if the audio is recording for it, but yeah, I think these will be useful. Um,
Yeah, a lot of these things is the stuff that AI just can't do for
yeah.
you.
Well, but I mean, like, what I mean is, I mean, this is part of it is like the translation.
Yeah.
Here I'm walking in not knowing it. I'm using my uh limited knowledge, and then I'm like, all right, let me go. I have an expert in my
I
life who can.
I learned so much more from the 3.5 years that I spent in Italy, working in the factory, working with these guys that were climbing around reactors and rail cars and tank trucks and all of that stuff. I learned so much more than if I'd have just been in the lab all the time.
Yeah, or if you're not even in a lab and all you can do is read the articles, which is what the AI is
Yeah.
doing. So again, when I try to say that, like, this is the bridge, um, of of I'm there's part of the what I wanted to do with this is like trying to connect it your um domain of expertise with my,
Mm-hmm.
as much as I pretend like this is my
And like I
domain.
say, I wished I still could work for another 2 or 3 more years. I don't wish for getting up early in the morning, but like I say, my last 2.5 years were the most productive that I ever had in terms of what I was turning up.
Well, maybe part of doing this is to help you find some more
Well,
contract work.
when another year goes by, and it's been 10 years since I retired, I'm going to give the flying Ben elbow to Sasshole, and I'm going to go ahead and find a way to get those papers published,
Yeah.
regardless of what they say.
All right. Well, unfortunately, I'm gonna hide this stream so they never see this
No,
stream.
no,
But
no. Let them see it. Let them see it.
I don't want to get you in trouble.
No, no, not, not.
I put the papers in the AI, by the way. Like,
Good,
it's okay.
good. Somebody's going to learn something about that.
I did. Hey. Anyways, I'm gonna let these cats in and go to the bathroom. But I love you, Dad. And
Well, take care of them.
yeah, I had this other like. No, you know what? We're just gonna do it however we do it every time. So,
Okay.
all right.
All
I'll catch
right.
you next time. Bye.